Okay, so hi, we're SolarCar. I'm Lizette, I'm the project manager.
I'm Thomas, mechanical lead.
I'm Gilbert, the electrical lead.
I'm Keith, and one of the business sub leads.
Cool, so let's get started. So a little bit about us. So the team officially started in the spring of 2017. We're almost hitting our 2-year-old mark. We started as a project under the Engineers for a Sustainable World, but we decided to branch off and become our own senior design project to share and spread our passion for renewable energy and sustainable transportation. So we first got the idea of starting a solar car by the American Solar Challenge. So this competition is every 2 years, and it's an 8-day, 2,000-mile endurance race across America. It's a pretty big scope, so what we've been doing is we've been designing our solar cars based on these regulations. So for the past 2 years, we've completed 3 SolidWorks full designs, and we are going forth with our last design, which is what we call our prototype car, but I'll talk a little bit more about that later. So what we're trying to do is we're trying to build a fully functional solar vehicle, but also spread awareness for renewable energy and also develop the engineers needed for industry by developing our technical and soft skills. So that's pretty much what we're all about. We're trying to attend the UCI Energy Invitational, which is next quarter. It's in April, at the end of April, so that's what we're really trying to go for. Yeah, so the Energy Invitational is a competition that Professor McCarthy founded, and yeah. Okay, so this is a team. We currently have 30 total members. We recruited 14 members this quarter, so we've pretty much doubled in size just this quarter. As you can see, there are 3 teams. There's electrical, mechanical, and business teams. And under the electrical mechanical side, there are 9 sub-teams. So there's 9 total subsystems that incorporated into our design. So we also have 2 cars. It might get a little confusing, but we're going to talk a little bit more in detail about that later. So we have the prototype design, which is essentially what we're going to UCI Energy Invitational with. This prototype design is pretty much an electric vehicle. There's no solar array attached to it, but this is our first ever car that we're building. So we just wanted to focus on manufacturing, practicing, testing, and all of that, since we've never built a car before and we don't really trust it to go to American Solar Challenge yet. And then we also have our production car, which is what we hope to be our solar car for the American Solar Challenge. And this is what we hope to just compete with, I guess. And the differences are just, this is an electric vehicle and the production is a real solar car. So this is our Gantt chart, and because the big focus this year, this academic year, is for the prototype car, this is what it looks like so far. In red, that's the design freeze. That's just the freeze in general, so that's when we hope to accomplish the fully built car, the prototype car, I mean. And so we also have our milestones and we have our deadlines as well, because there are certain documentations due and presentations that we have to do for the invitational. So this just is all about the invitational. And we have 3 main apps that we use. So we have Google Drive for our files and organization. We have Slack for our main form of communication, and we also have, or we just recently started using Asana, which is for task management, and it's been a lot more efficient to go through all the tasks in each sub-team. And there's even little Gantt charts made for us. And we've recently just started using these to implement for our designs and manage our designs, because we needed version control, so we stopped using SolidWorks, and we're just going to be using Autodesk Fusion 360 and GitHub for electrical schematics and other designs. So I'm going to pass this off to Tommy now.
Alright, hello everyone, I'm Thomas. I'm a little sick right now, so if I'm talking kind of weird, I apologize. I'm going to start off by talking about the mechanical sub-teams that we have. So we have 5 sub-teams. We have chassis, aerodynamics, suspension, braking/human interface, and steering. So on this slide, you can see we have chassis and aerodynamics. Our chassis team is responsible for like the body of the car, which is, or not the body, the chassis of the car, which is like the thing which all other components are built upon. The aerodynamics team is responsible for the body, so their main goal is to get the body as aerodynamic as possible to optimize our motors. Oh, sorry. So here we have suspension. The suspension's main goal is to give the driver as comfortable as a drive as possible. It's a 2,000-mile race, so we don't want to have super hard suspension, and we don't like good. That just get annoying. So we have braking and human interface. So human interface has recently just added the braking, and they're responsible for kind of the human-car interaction. So they're doing like dashboard stuff, steering wheel stuff like that. And they're working with electrical and the auxiliary electrical system. And also they're responsible for the brakes as well. You know, how do you stop the car? And our steering system is responsible for steering, so turning the car. That's pretty important. So now I'm going to talk about the prototype progress that we've made this quarter. So one of the main things that we've been focusing on is our suspension sub-team had to redesign our uprights, which you can see there in figure 16, to fit bike wheels. Gilbert will talk about this more later, but we made this switch for the prototype car to bicycle wheels, basically make it cheaper. So in the back, we're running e-bike motors. Instead of $17,000 really high performance motors, we're using $160 e-bike motors. So it's much cheaper, but because of that, the entire suspension system had to be redesigned. We kept the same control arm geometry as well as the steering geometry, but we had to redesign the upright to that kind of hook shape. So it's kind of reminiscent of like a fork that you'd see on a bicycle, and this allows for more support of the bike tire, that way it's supported on both sides. And it's also cheaper and easier to manufacture. Now on that note, our aerodynamics team has also redesigned the body. So as Lizette mentioned, since we're not using a full solar array, we don't have to have a hard, flat surface to lay the solar panels on. So the aerodynamics team decided to go with like a World War I plane design, where it's made out of ribs, spars, and then like fabric stretched along. So it's basically just really tight wound fabric. It's a lot cheaper, and it's a lot easier to manufacture than fiberglass layups. And then also, as I've kept mentioning, we've been doing a lot of manufacturing this quarter. So here you can see some stock that we have. This, if you guys want to know, that's for chassis mounts for the control arms. And that's been a pretty big focus this quarter. Now for the production progress, as Lizette mentioned, we got a lot of new members. So all the new members have been working on the production design, which is a new design of the car meant to go to the ASC. And as Lizette mentioned earlier too, this is all being done in Autodesk Fusion. So the reason why we switched to Autodesk Fusion is there's easier version control, and there's no like weird issues between like SolidWorks 2017 and SolidWorks 2018, where those two aren't compatible. You can't import 17, or you can't import 18 into 17 and stuff like that. We had issues with that this quarter, so it just made the switch to Fusion a little bit easier. And now I'm going to hand this off to Gilbert.
So, hello. So, I'm the electrical lead in case you already forgot. And basically our electrical team is split into 4 different sub-teams. The first of which is the battery. The battery is basically the vehicle's main source of energy storage. In a production car, it's going to be about 115 volts, 5 kilowatts. The second sub-team is telemetry. Basically, they're responsible for designing the embedded systems and the onboard computers of the car. The third sub-team is motor. They're responsible for integrating the solar array and the battery and making sure that the car uses every bit of energy as efficiently as possible. And the fourth sub-team is the solar array. So basically, they designed the solar array on the car, make sure it's encapsulated properly, and will be protected at all times during the race. So, let me start off with our prototype car progress. So this quarter we had 2 goals. The first of which was to design the user interface. So basically this is just going to be a little LCD display that the driver has. So kind of like in a Tesla, they have that big old LCD screen. We're going to have a little Raspberry Pi LCD screen. So the purpose of this is to kind of give the driver metrics such as battery voltage, battery state of charge. And so far the design of this has been going pretty well. We expect it to be fully functional at the Energy Invitational. And the second goal for the Energy Invitational is to design a very small scale powertrain. So basically this will just be 4 12-volt lead acid batteries, as shown in this picture, and 2 bike-up motors. So those are around 1,000 watts each. And as Tommy mentioned before, the reason why we went with this design was because it's way simpler than the design we want to use in ASC, and it's also a lot cheaper. So now let me move on to our production progress. So we had 3 goals in regards to this. The first of which was to test out our CAN network. If you don't know what CAN is, it's basically the protocoling system that the onboard computers use. This is standard in automobiles. And we tested out a very small version of this. Initial tests were successful, and we plan on scaling this up next quarter. The second goal that we had this quarter in terms of our production car was to test out solar encapsulation methods. This has been going slower than expected, mostly because most of the supplies we've been buying have been coming from like pretty far away, so they've been taking forever to get here. But we've started out testing some stuff. Initial tests weren't really successful, but next quarter we think they will be. And then the third goal in terms of our production progress will be, we're actually designing a 48-volt lithium-ion battery that will basically put in a prototype car and simulate what the big 115-volt battery that we actually plan on using. So we're actually in the progress of building that at the moment, and we actually got the unique opportunity of wire bonding it. If you don't know what wire bonding is, it's basically like a method of connecting the batteries, and it's pretty cool because like Tesla's use this, and a whole bunch of startup automotive companies actually use this technology. So we got the opportunity of testing this out at the Advanced Power and Energy Conference. So now let me hand it over to Keith.
All right. I'll try to make this quick for business because I know you all are engineers and don't really care about the logistical stuff. Once again, I'm Keith. I am one of the business updates. So the business team is normally focused on the logistical matters such as our finance and outreach and social media. As you can see here on the left side of the presentation, this is our budget for our SolarCar prototype car. It's composed of mainly the components that Tommy and Gilbert mentioned before, like the motor, the solar cell, and auxiliary battery. And the total is around $12K as of right now. This is not including the miscellaneous stuff, like the small expenses that we have. In comparison to the actual production car, our production car is actually estimated to be around a budget of $70,000. On the right side over there, you have the spreadsheet for account balance, which is our method of tracking the purchases that we make and seeing how much money we have left for funds. Typically, when we are out of funds, our main source of income is by reaching out to sponsors. At the moment, we are currently reaching out to a lot of sponsors and in hopes of getting contact to see if they would donate either their time, money, or even their support. Our other second means of getting income is actually one of the focuses that we've been very working hard to get completed this quarter, which has been our crowdfunding campaign, which is through our school's platform of Zopfunder. Our goal at the moment for the Zopfunder is to achieve a goal of $15,000, which will mainly be used for the actual production car. At the moment, it's like day 37, which means that we're 37 days left in the progress. We have approximately 20% achieved out of the 15K. Move on to the second slide. Oh, shoot, sorry. This is our second main focus for the rest of the quarter is that we've been trying to work on the social media and marketing outreach part of the program. So over here we have on the left side we have our newly renovated website with our updated profiles of team members and like our progress. In addition to that, we also have our sponsorship packet, which is the information that we give to sponsors who wish to learn more about what our team is all about, the goals we have made, and as well as all the progress that we have also completed. And for the right side, we also have our team's Instagram and Facebook, which you guys should follow to garner some support. But yeah, that's that for business. Are there any questions? Thank you so much.